Hey y'all, CB here once again at NBS Welding. Y'all want to see what I got in the shop? Sure you do, or you wouldn't be here. Bobcat excavator, little mini hoe. My buddy's little mini hoe here got a little blade issue. You can see how where there's the holes in this have gotten big enough that it's tearing. This steel right here that's sticking up is sticking up. That's actually steel. It's steel that peeled up from that hole. So what's going on here? Bobcat doesn't seal weld these completely shut. When they put the gussets on them and they put them together, like if we look at the very end of it, there's a weep hole right there. You wouldn't get a whole lot of stuff in that weep hole, but eventually you're going to get dirt in there. So you get dirt in there, the dirt holds moisture, and the dirt keeps the moisture against the metal, and then you get corrosion. And that's what's going on. You know, that, of course, yes, it's a blade, and it's partially worn away, but a lot of it's gone just because of rust. It rusted away. And I want to show you up under the bottom too. I think we got more corrosion on the bottom than we do wear. So these places where pretty much it's packed full of mud. The mud has held the moisture against the steel. There's been some wear, you know, some of the steel would have worn away, but a lot of it's rusted away. So one thing that we can't do is we can't keep this happening. If you don't do something about this, this will be gone. If you don't do something about that, that'll just be gone. Because what you've got right now on the front of this blade, where you're actually going to be pushing stuff, you've got holes that are big enough where the material that you're pushing is going to peel it. Just like it did on this one where we see that the steel is kind of peeled back and mushroomed. So I don't think you want to go OCD on this repair quite yet. I mean, obviously, I'd love to just, the thought honestly crossed my mind to just cut the whole blade off, throw it up on the table, and plate it and seal weld it so that there would not be even water or dirt to get in it. If you do that, you're probably putting more into it than it's worth, honestly. You know, you don't want to, we want to get some more life. We're going to extend the life of the blade, and we're going to, you know, add a lot of use to it, by patching it with a piece of mild steel. That's what I think we should do. That's not going to take a lot of time. It's not going to be a tremendous amount of work. You're not going to have a whole lot in it, and you'll get enough life out of it to justify what you did. And another thing is, this being a buddy of mine, we'll see how that does. I may be making the bad call, but I don't care. You know, it doesn't scare me. You know, if he got a very short period of use out of this and said, hey man, that repair's not great because we didn't get that much use out of it for the amount of time that we've used it, it's already shot. Well, then I'll do something different. You know, before we go and put way too much in it, let's just put a little in it and, you know, I'll throw a piece of flat bar on there, weld it up. Obviously, I'm going to have to take a torch and cut some of this mushroom steel out of the way so I can get a patch on it. But I think it's the right thing to do to not do too much to it, because you don't want to have a fortune in something that, you know, it's not that big a deal. It wouldn't be a huge deal to build an entirely new front blade section and put on here. But if you did that, you'd really have something. You know, you'd have something that was going to last a long time. If we were to cut this blade right off the machine, throw it up on the table and plate it, you might have more work in it than what it would take to build a new one. And I don't think he even wants a brand new one on this machine. You know, it's not a brand new machine. He's going to want to get some more use out of it and go with that. So I'm going to get the torch out and get going on this thing, and we'll do a quick repair on it and see how it turns out. Knock that out quick, no big deal. That'll get him some more life out of this thing. That's just a piece of 1/4x4 flat bar. And it's a mild steel flat bar, so it will wear away. Although it's thicker than the original material, this original skin of the blade is a harder steel. The stuff they use to face the blade would be a lot harder than the mild steel that I just put on there. So, you know, that 3/16 skin that Bobcat originally put on there would probably outlast the 1/4x4 flat bar that I just put on there, even though the 1/4x4 is thicker. The mild steel is a lot softer. But what we did across here, there was some MIG and I did some stick. Most of the top of that I MIG welded. That was 035 solid wire and 7525 mixed gas. And I ended up stick welding all the way across the bottom. Now that was where you've got mild steel being welded to a cutting edge, and this cutting edge is the hardest steel here. This would be the hardest, most brittle on it. This would be even harder than the skin of the blade. Now, if all I had was MIG, I probably would have MIG welded the bottom too. But I do believe you get a little more elasticity and a little more forgiveness with the stick. You know, more crack resistance and elasticity than you do with a solid wire MIG. I haven't had a lot of trouble welding hard steel with a solid wire MIG. I just know that, you know, over the years of seeing different MIG welding on different applications, the solid wire MIG doesn't have quite the elasticity of the stick. Now, the stick was really fast on this because of its size. I was running a 3/16 7014. 7014 is a high deposit rod, and it contains an iron powder. There's an iron powder in the flux of a 7014 that becomes weld metal. So when you have a 7014, that's one of the welding rods, one of the few welding rods where, you know, there's actually an iron powder in the flux that becomes weld. Another rod where that takes place is a 7024, which is another structural rod. That's what we call jet rod. And, you know, those will really lay down some weld. They will get a lot of deposit done in a short period of time. You can run a lot of amps, but with the 7024, that's a flat and horizontal only, and I really only use them flat. The 7014 is a high deposit. It does have the iron powder in the flux that becomes weld metal, but it's an all position. You can run it vertical, horizontal, overhead. It's tough to run overhead. It's very fluid. Actually, if I was stick welding overhead, it wouldn't be my choice. But on this horizontal right here, you know, you're going up all the way up to the diameter of 3/16. That gives you a lot of deposit. And, you know, on a weld like that, you can reach 1.5 feet or more with one rod, which is, you know, that's getting it done. I was stick welding the 3/16 7014 with the XMT 304. Let's see where I was at on there. 185 amps. So, you know, that's pretty hot. Of course, I run the 1/4 inch 70/24s, you know, 280 amps. When I'm really getting stuff done, so that's a whole 100 amps more than that. But any hooser, same shop, same CB here at NBS Welding, same no BS welder, but different mini hoe, same customer. My buddy that owns this hoe, same guy that owns the last hoe we just got done working on. And he's got an issue with the same part of the hoe, but a different issue. Now, if you look at the face of this blade, it doesn't have holes in it like the one we just fixed. But if we look right around here, around the back of her, around the back, we see some cracks. Whenever I first saw this, I said, what have you been doing? You've been running down the fence row, pushing fence posts over with the center of the blade. And when we look close at this has been welded before. As flush as that weld is, it looks like it's probably been gouged out and welded before. So we're going to want to put a plate on this. We're going to want to gouge this out and do something to plate it and reinforce it and try and stop this from happening. Let's talk about this for a minute. So when I say let's talk about this for a minute, what I'm talking about is metal fatigue. And I've talked about metal fatigue before. It's been a while, but when you have cracking like that, you definitely want to weld that up. And the reason you want to weld it up is because it's not going to get smaller. You continue to run that machine with that crack in it, that crack is going to continue to crack. It'll keep going until you break a blade in half, or whatever piece it is that you've got. You know, and the thing is, like, people see me weld up different stuff, and sometimes even I'll put a plate on something and I'll weld up, I'll gouge out the cracks, I'll weld up the implement, and when the implement's welded up, I'll do some plating on it like we're going to do here. We're definitely going to want to add a plate here and try to reinforce that to stop that cracking. But people see me do that and they say, oh, that's better than it was when it was new. I wouldn't necessarily say that. Just because you've gouged out cracks and welded them up, and then, you know, you might have plated it to reinforce it, you have not removed the metal fatigue from that implement. And I want to talk about metal fatigue because it's something that I think you want to understand when you're talking about welding, or you're talking about, obviously, we don't want to throw this blade away. We're not done with the blade. There's a lot of life left in that blade. But we can't leave it cracked like it's cracked right now, because if we do, it's going to continue to crack till it breaks in half. But no matter what we do, it's still going to have that metal fatigue in it. And I just grabbed a 7018 welding rod. This welding rod is made of some of the most resilient steel that you can get. And I want to use this as an example just to show you something visual about metal fatigue. This rod is made of some of the most resilient steel you can get. I can bend that rod until both ends point in the same direction. That rod's fine. Didn't even hurt it. I can even go back the other way. Look, I just bent that completely around the other way. It's still fine. This is extremely resilient steel. But, see what I'm getting at here? As an implement is worked, and it does a certain thing, and it repeats doing that thing over and over again, it could happen a million times. Tiny little cracks are going to form because you're creating fatigue in that material. It doesn't self-heal, like our muscles do. When it forms those little cracks, those cracks aren't going to heal. They'll never heal. When we see the crack and we gouge it out and weld it up, we have healed it to some extent. If we reinforce it by welding a plate on, we've strengthened it to some extent. But the rest of the implement still has metal fatigue. So, although this welding does extend the life of an implement considerably, greatly, it's a very efficient thing to do these repairs, because we'd be wasting way too many resources to take a blade that's just got a couple cracks in it like that and take it off there and put a new blade on it and throw that one away. That would be extremely wasteful. We can get lots and lots of life out of that blade. We can probably get enough life out of that blade for that blade to last the rest of the extent of the life of that hoe. Very possible. So no, just because something's cracked, you don't have to completely replace it. But don't believe that because you've gouged it out and welded up some cracks, maybe even plated it, that it's better than new. That material still contains metal fatigue. And this is my best explanation of metal fatigue. Hey, let's get to work on this and get this thing fixed and extend the life of this blade. Well, I think that's all the excavators this feller's got for me to work on right now. We had that big crack there in the center, gouged it out and welded it up. I found a crack right there, one right there that we gouged out and welded up, and then I added a piece of 1-inch square bar that's going pretty much center to center on these struts. So he can get some more life out of that with that braced up like that. And I want to thank y'all for watching. Learn how to work with what you got. That way you always have everything you need.